AI is evolved from the beginning to now. What are the future direction and what are the key concepts involved in that? And I also got the opportunity to work as postdoctoral scientist at the Airbus Space and Defense Division in Germany. So the topic for the usability of AI in space application is quite relevant to me. However, due to the company policy, I cannot share the exact work, but I will at the end of the session, I will uh, provide the key insights like on what topic they are working related to the space applications. So I will begin the slide with the foundation of artificial intelligence, which comprises what is AI, how it evolved, and why does it matter now, and what is the future. We also try to cover the some bits which are roaming around the AI, and we'll try to bust them. So the brief history of AI. So first point to be noted that it is not a new term. It is invented like 70 years before in 1956 in a one conference organized at Darmstadt in Germany. So then in 1997, IBM make a revolution where Chase AI beat the world champion Kasparov, and then we enter in the era of machine learning. But still, our process, the capability of these models were limited by the data and the computation available at that time. So in the beginning of 20th century, we make a new leap from moving from machine learning to deep learning. So the key term of deep learning was coined by Geoffrey Hinton, and it solved the flat curve problem of machine learning. So if we get during that period with the simultaneous evolution of sensor networks and IoT, we were having the abundant amount of data. But the problem with machine learning models was that they are not able to process that large amount of data. So the performance increases linearly, and at a certain point it get flats. They are not able to perform after a certain point of time. So we are getting a flat curve or a plateau thing. So for that, we move from machine learning to the field of deep learning. And the more revolutionary work in the deep learning came around 2016, where AlphaGo, which is a product AI model and developed by the DeepMinds, which is now a subsidiary company of Google. They produce a AlphaGo model which beat the world Go champion. So it is a kind of simultaneous revolution, like 1977 to 2016, where a machine learning model beat the chess champion. Here, the AlphaGo model beats the Go champion. So the game of Go is considered more complex compared to chess. And now, currently, we are in the era of generative AI. So I hope everyone in the research dimension are using these models, and majority of the audience, I believe, are from the engineering background. So we are aware about these various large language models. So this is a overall evolution from 1956 to till date. So we'll focus on the terminology based on this slide. I will categorize the for the discussion is we'll focus on the key terminology, how this entire baggage of artificial intelligence is made, what are the key components, and what is the functionality. So as I discussed that AI is all around. So these are the common applications which are using in our day-to-day life, which is supported by the AI. So your Google Maps to predict the shortest route based on the traffic condition, weather conditions. They utilize various parameters and predict what will be the suitable route based on the given source and destination. That net banking applications, your YouTube and Netflix, which is using AI for their recommendation. Face unlock, which mostly we are using in our mobile phones, which is using a convolution neural network, one of the network used for the image-based applications. Email spam filtering, voice assistant. So we are using various type of voice assistants such as Siri in Apple and Gemini kind of thing in your Pixel-based phone. Then ChatGPT. So everyone is aware about GPT. So it is a generative AI based model, which is using in the background your large language model to generate the text. And finally, Google search. So these are the key day-to-day applications which is backed by the AI in the current era. So these are the few myths that we'll try to debug, or we'll try to make these assumptions false when this session will be completed. So first myth, that AI will replace all jobs, but this is not truly correct. How it will not replace all jobs, this aspect we'll cover when we discuss the various components of your AI models or machine learning models. Then second myth is AI understand and thinks like human. So still we are in the in terms of development, we are in the basic era of AI. Still, the general artificial intelligence and super artificial intelligence, which is considered as the equivalent and superior compared to the human thinking, that road is still far. So, still, AI can be good at a particular given task, but it cannot think like a human or make a context among various tasks. And third, myth that AI output is always accurate. So still, it is not relevant, because if you observe, when we type something or when we ask from ChatGPT to generate some response, there is always a line that AI can make mistakes. So still, your AI models are not 100% accurate. And moreover, the recent industrial revolution, that is Industry 5.0, so that also make a very strong assumptions that there will always be a human in the loop. It is known as human in the loop concept. So we have to verify these results through that person, whether it will be a supervisor or it will be a manager or it will be an analyst. So we have to verify the results produced by these AI models. And final myth is that AI is a brand new version. So again, sorry to say, but maybe for some people it may look like, from the branding perspective, it is a new, but it is a very old research which was stopped due to certain reasons, specifically due to the limited availability of data and limited availability of computational resources at the given time, which is also known as the winter of AI. So now that winter of AI is over and it is more flourishing compared to the previous years. So these are the myths, and we'll try, when we'll cover the various concept of AI, we'll sort or will make these assumptions true, that these assumptions make these assumptions false, like AI will replace all jobs. So when we'll go into the concept and components of AI, we'll make this assumption false, that why AI will not replace all jobs. So uh, now next we'll move to the fundamental of AI. So it comprises like what is the familiarity of AI, how it is evolved from where it began. So the key concept we'll cover into this, like artificial intelligence, machine learning, deep learning, and generative AI. So if you think from the perspective of Venn diagram, so AI is the larger subset. Then a particular subset of that AI is machine learning. Then a particular subset of machine learning domain is deep learning, and very specific subset of deep learning problems is your generative AI solutions. So the hierarchy of AI evolution is depicted here from bottom to top fashion. So the larger subset is AI, then machine learning, then deep learning, and then generative AI. So now how we'll differentiate them, and it is very essential to know the distinction between these key technologies. So artificial intelligence is a mechanism which enable you to think like the humans. So based on the cognitive functions and how we'll make the decisions. So it can be your rule-based mechanism, your data-driven mechanism, or your feedback-based mechanism. Now how we'll use them. So initially when AI models were developed and the during like 1970s, 1980s, so these models were based on rule-based mechanism. So your rule supposed to be fixed, but when the scalability of system grow and the rule become complex, so it is hard for humans to make all possible rules. So these solutions are suitable for small scale systems, but not for the complex system. Then machine learning came into the picture. So it is a kind of a statistical technique where we have abundant amount of data, and through that data we have to learn, like what we need some mechanism that can extract the key features or key knowledge from data. Based on that we can make the predictions. So from AI to machine learning, we move from rule-based system to learning-based system. Then with the era of your IoT and sensor networks and various remote sensing techniques also we can include. So we have abundant amount of environmental data. It may be your imagery data, satellite data. So machine learning model becomes constrained in terms of their performance on that large amount of data. So we move from machine learning to deep learning in the context of size of the data and complexity of the models. And again, these deep learning models are much of the approximation result. So it's kind, you can consider it as a function from set A to set B, which will provide the mapping. And finally, we are in the era of generative AI. So in your deep learning, the key models were your, in machine learning, your key models like Bayesian networks, decision tree, K-means clustering. Then deep learning, the key revolution was your neural network. So it was your artificial neural networks, which is further developed for specific type task. So for the image kind of task, we develop convolution neural networks. For the sequence learning, we generate recurrent neural network. So these were the key models that developed during the deep learning phase. Now in the current era of your generative AI, we are using that sequence learning model and transformers, but in the context of your language, your natural language. So generative AI, we can say it's a part of your natural language processing and the sequence model of deep learning. So now we will extend this discussion from AI to generative AI in a bottom to top fashion by going through the key definition. So AI is the science of making machines that can perceive, reason, learn, and act. So as a human, when we take some actions, so we use our senses. So our senses are used to collect the data. So to accomplish the task in computer systems or in machinery, we use various kind of sensors. So that is to perceive the information. Then for reasoning, as I described in previous slide, they use different mechanism for reasoning. In AI-based solution, we will use rules. In machine learning, we will use some statistical mapping. In deep learning, we will use various learning models, and similarly for generative AI. So for the perceive, we have to collect is a data collection phase, then making the reason, then learning from that reason, like setting the particular values of the neurons in human brain and select a threshold value, like when a particular neuron will get fired and act accordingly. So it's like a complete close feedback loop. You start from the perceiving, then learn, reason out or make a decision, and learn, and finally act on the given decision. So we try to embed same kind of phenomena in the machines, and artificial intelligence is a technique to enable that phenomena in the machines, which is learned on the basis of your human intelligence. So for the learning of these patterns, we use a data set, which can be a tabular data such as environmental data or patient healthcare data, your sales data. It depends on applications, or it may be your imagery data, speech data. So it totally depends on what kind of application or what kind of problem you want to solve using the AI. Then we make the prediction. So how these predictions are made. So there is a mathematics behind that, which uses your loss model and activation function. We'll discuss that part. And finally, we'll make the decisions. So it's kind of a mapping from human intelligence into our day-to-day activities, or how can we enable that human intelligence level thinking into the machines. But as I mentioned, that still we are in the very basic era of AI. So now the journey from this basic AI to AGI and ASI. Sorry. SAI, like generic artificial intelligence and super artificial intelligence, is still far. So this is about the AI. Now we'll switch to the machine learning. So in traditional programming, like for assume a C program, so our rules were very clear and it is defined by the programmer. Suppose if I want to set a threshold on the temperature, so I will write that if the temperature is less than this, activate the alarm or don't activate the alarm. So it's a if else loop kind of uh, programming, which is defined by the human or which is defined by the programmer. So it is a hard code kind of thinking, which I cannot make flexible. And for this approach, it should be very clear that the programmer or who is the person taking the authority to designing these rules should first, it should be a domain expert. Because if I want to design a system for the medical operations, then I need the help from the doctors. But if I want to design a system for the manufacturing plant, so I need some expert who can help me out in defining the rules. So your traditional programming approach, you need two person, one who can define the rules, and second, the person who can code them for you or who can make a system. So here dependency on humans is much high, or you can say dependency on domain experts were very high. And if system is very simple, then defining these rules is not a problem. But as the scalability of your system increases and rules become complex, what I mean by the complex rule, see in the next few examples. So if the complexity of rule increases, so it will be very high, or there is a possibility that we may miss some rule, which may lead to the catastrophic failures in kind of in case of your medical scenario, in case of your manufacturing scenario. So your machine learning reduces the dependency on your domain experts. It enable a machine to learn from the data. So how that learning is enabled? So that learning is enabled with the statistical based learning. So we train some model using a given algorithm. It may be a gradient descent algorithm, which is generally used for the learning. And based on the given amount of data, we reach to certain mapping that how these inputs and outputs are co-related, and based on that learning will make the prediction in the future. So here human dependency or the dependency on your domain expert is reduced, but the efficiency is highly dependent on the amount of your data and the quality of your data, as well as on what kind of model you are using. So these are the considered as the performance parameters, quality assurance parameter. How will how these affect the performance, that also will cover in the upcoming slides. And kindly also let me know if I'm going too fast, so I can slow it down. Ma'am, is it okay? Hello, ma'am.
Yes, sir.
Ma'am, I asked if I'm going too fast, so I can slow it down. So kindly let me know as per your convenience.
No, no, sir, you are all right, sir. Please go ahead. Go ahead.
Okay, thank you, sir. So now I describe like how your machine learning model will learn. So we need some features from the data and will learn them. So first I will compare the traditional programming approach, then I will move from traditional programming to machine learning. So let's say there is a doctor and it's a description of how we'll make the decision. So when you will visit a doctor regarding certain disease, so we'll ask you about how are you feeling. So we'll ask some common questions like whether you are having skin rashes, or there is a fever, or you are suffering from headache, you are having cough or not, or you have vomit in last few hours. So these are the judging parameters, or we can say these are the key parameters. By making the different combination of these parameters, the doctor will reach out to a decision. So if few of the parameters are satisfied, so the doctor can conclude, okay, you are suffering from a dengue, and accordingly he will give you the medicine. So from this image, it is very much clear that to make a decision, we need certain inputs. And that inputs, in terms of your machine learning, we describe them as a features. And these inputs are processed. So for time being, we can assume that processing unit is a black box, which comprises certain logics. So in case of your doctor, since he is an expert, he studied for he dedicated a long duration of during his education to understand like what are the parameters be there to identify whether it is a dengue or not. So he can be considered as a domain expert, and based on this domain knowledge, he make a final prediction or final decision and accordingly prescribe the medicines. Similarly, so these are the various, as I discussed, these are the various combinations of your inputs. You like, and in only the third row, so which is comprising you are suffering from the rashes, fevers, headaches, simultaneously vomiting, it may lead to the dengue. Other may lead to the other disease. So this is a common practice. So the next figure, which is right hand side, describe these inputs in terms of your more mathematical intuition in a binary format. So the simplest format is like if you are suffering from all the, you can use or AND gate or gate logic, depends on logic described by your domain expert. So you can reach to the final conclusion whether you are suffering from a particular disease or no. So it is quite clear from this figure that to make a decision, we need certain input, a processing, and a processing unit. That processing unit comprises the intelligence which is defined by your domain expert. So here, in case of this healthcare application, our domain expert is a doctor. So we can take his intelligence defined in this third row to make the rule that if I will go through such kind of parameters in upcoming future, so I can describe that this person is suffering from this particular disease and automatically can generate a subscription for that. But now consider that from a healthcare application, there are n number of diseases, and for a particular disease, there is a particular specialist. Now within the particular disease, again your parameter can fluctuate. So how hard it will be to encode these rules by hands. So that's what I mean by the complexity of the system. So if I want to design a system only for the dengue disease, it will be very easy for me to code these rules. But if I want to design a generic system for the entire healthcare system, it will be very hard for me. In terms of cost also, I have to hire a n number of domain expert, and in terms of complexity as well. So this is the key limitations of your rule-based decision making, which is initially adopted by your AI methods. So here we can say that these systems are suitable for your small scale work. So still we can say that AI is relevant, that rule-based systems are relevant, but it depends on the complexity of your problem as well as the scalability you are expecting from your system. Another example is a cricket match. So there is an umpire, and we have umpire has to decide that whether the out, the if a batsman is out, so whether he is a leg before a wicket or not, LPW out or not. So for that we have to check n number of parameters. So one is like your ball is pitching in line or not, whether the impact is hitting or not, whether its height is above the stumps or it is hitting the stumps, whether the front foot of bowler is above the line, or whether the batsman attempted the shots or not. So again, when we move from the healthcare sector to sports sector, so your features are changed. So a doctor cannot describe this input to me, these features to me. So for that, I need to hire the expert from the sport industry. So again, I can decode these parameters in terms of your binary format, since it is easy for us, and then we can describe the rule. But now we are moving to the limitations. As I already discussed, it depends on the scalability of your system as well as the complexity of model. So now there is a person, I want to design a system to hiring a person based on his academic criteria. So I will include all his marks through his academics, his projects, his publication, and various awards, and make certain thresholds. So based on this thresholds, I will decide whether I have to hire that person or not. But what about the biases? I can, if and what about if the rules are much complex? And what about if some rules are not inexpressible? So there can be some complex rule which I can create by making a combination of certain given inputs. So if your rules can be complex, these are the in terms of your limitations, and sometimes your rules can be inexpressible, so it leads to the catastrophic failure. And rules sometimes are unknown to us because we decide the rule, or the domain expert will decide the rule based on his experience. So there can be some phenomena or some events which he or she may not observe during his tenure or for working on a particular problem. So still we cannot say that a domain expert will give you a guarantee for the 100% correct rules. Some events may miss which can occur in future. So we are not able to decide or predict them what is the nature of that event. So if I go in the context of a manufacturing, so if suppose expert is working from last 10 years and it did not observe a particular kind of failure, or let's say a person who is working on a petrol or diesel engine based car, now I cannot use his intelligence for 100% correct results on EV based vehicle. So these are the limitations of your rule based system. So then we move from artificial intelligence or rule-based system to learning-based system. So in learning-based systems, we map the given input to the output using some learning function. So this is a very simple example. Here, rather than having the data of a single person, we are having list of data of n number of candidates who are applying for that particular positions, and we have to use a mathematical model that can decide or that can predict whether I have to hire that person or not hire that person. Now here that learning rule, I have the learning rule will not be defined by the programmer. Here the learning rule, your model will itself learn. So how that learning process will occur, that we'll see, because it comprises certain components and mathematical function. So for time being, we can assume that within this machine there is a black box, or there is a model which will initially learn from this given amount of data. So suppose this is uh, a separator. One side is having black points and one side is having blue points. So in red part we say don't hire, and for the blue and for the data points, which is basically the credential of a particular candidate. So for the data points which are falling in the blue region, we'll say we'll hire them, and for the red part we'll say we'll not hire them. So how this decision boundary is made, so that is made by your model. Now it may vary and depends on what kind of model you are using and what is the requirement of your application. So how that mathematical model works, we'll see in the component of your machine learning or component of AI. So till now we move from rule-based learning to the systems which can learn from the data. So now we'll see that what is the fuel of machine learning. So the fuel for the machine learning is data, and we are getting the data at each and every place, whether it is a social media, whether it is your healthcare devices or your tracking devices. We are having an abundant amount of data. Even within the current era, we are having the smart devices at our homes. So we are collecting the data through our refrigerators, we are collecting the data through our washing machines, through our uh, intelligent vehicles. So we are having the abundant amount of data. Now the task is to how to process the data in an intelligent fashion that we can extract the key insights from that data. However, there is another aspect in certain applications that along with the efficiency that data should be processed as quick as possible, but that we go in the network, and I think that is an essential parameter for your space-based applications. But here we'll focus on the efficiency. So the fuel for your machine learning models is the data, and the characteristic it should follow that your data should be clean, and it should has the capability. It should it should not be the it should be clean data. So these are the steps for the various social media data. These are for the healthcare data. So now we move from that. If we are given this data, now how will move from data to the decision using the machine learning. So first component is your data. It can be your tabular data, it can be your imagery data, it can be your voice data, or it can be your video data. That depends what kind of application you are using. So now we are having data at our hand, and our key objective is to get from this data to final decision. So what are the other components that we'll utilize in this journey to get the final decision with the help via the approach of your machine learning? So next we need the task, what we want from our data, whether you want to classify your given data, whether you want to detect your given data, whether you want to make the predictions from your given data. So there are the different kind of tasks. So in the context of image, if I describe, so if an image of a cat is given to you, so whether you want to classify it as an animal or not animal, or further, whether if it is an animal, so what kind of animal it is. Fine. If it is a cat, so what kind of breed of cat it belongs to. So these are the part of different tasks which we can perform on the given data. So second component of our machine learning journey is the task. So these are the various kind of tasks which can perform on the given textual data, or which you can use from the social media. So you can take the review to answer to generate the answers for your frequently asked questions, or based on these reviews you can generate frequently asked question, and by analyzing these data you can use it for the recommendation system. So these are the tasks which I can perform through this social media data. Similarly, through the multimedia social data, now as I describe in the context of image, what I want to get from the data, what is my task. So first is like you want to detect the object. This is the example of your object detection, like it is giving the name of your actors. Second, whether you want to detect the phenomena, like what kind of activity is going on. Third example is whether you want to detect the surrounding. So these are the different tasks for the image based data. Similarly, you can generate different tasks for your sequential data, for your textual data as well. So these are the two major category of task. One is your classification, so where we generally use for the category when we have the mapping of data in terms of category, and there is another category which is your regression based task. So here your output is a numerical value which will try to predict using the machine learning model. In second category, we try to group the task. So it is a category of your unsupervised machine learning based algorithms. And the generation of new data, which is we are using right now, image generation, text generation. So it is also part of your unsupervised task. So now we are having data and we know about the task. So two components are already built. Now based on the given data and what we want from that data described in form of task, we need the models. So what is the mathematical formulation of a task is described as the model. So suppose we are classifying a particular problem. So let's say, assume it's a very simple scenario. It's a binary classification, whether it is a dog or not. I'm not considering the multi-class. So for the simplicity, consider it is a binary classification problem. So whether it is an animal or not. So at the end, I will get this y, and this y will be represented in terms of 0, 1, 0, 0, 1, 0. So basically these are the, if it is 1, so it means that class is my final output. So now how my model will learn this, that is the key question. So initially we are given a large set of data which comprises your input and the true mapping of those input to the output. So how these are related, so that we call the true output, generally defined by y. And based on this data set, we learn that we learn the parameters of our model using some functions. And when our model got trained, we give an unknown input which is not seen by the model during the training, and it will predict its value. So it may be a binary value or it may be a probabilistic value. So higher the probability indicates that higher the chances of the given input to belong to the class for which we are getting the higher probability. So this is a mathematical representation of your model. So our model will be here f not x. So we are predicting the y hat with the help of our f hat. So it is not the actual prediction. It's our actual modeling is there exist in the given data set. Based on that given data set, we learn the approximation with the help of this y hat, which will utilize to predict using this f hat x, and using this our approximation will predict the y hat for a given new input x. So it comprises certain mathematical function. Based on that, we will establish an approximate mapping between x and y, which will be utilized to predict your y hat. So now your fx can be in form of a linear function, it can be a quadratic function, or a more complex function. So the simplest function is your a linear line which is separating the data. So it can be in the form of your y equals to mx plus c. So it is separating your data, but still we can see your data is not linearly separable. Here it is much complex, so this model will be not an efficient solution. Then we can go for the more complex model and much more complex. So as we increase the complexity of model, we need more computation. So we need to take care of that trade-off, that what we want, and again it depends on your given applications. So till now we covered three aspects. We have certain data and certain task for the given application is defined, and based on that we have to choose the model. So these are the approximations for our different model, and depends on the complexity of problem, we can also increase the complexity of the model as well. So now we have covered data, task, and model. Now next, and one of the important parameter is your loss function, which will define how your model will learn. Because still I did not have any clue that how the parameters. So here in terms of parameter, what I mean, so suppose for the first, if I'm using a linear model y equals to mx plus c, so m is my parameter, m is unknown. If I'm using x square plus bx plus c, a quadratic function as a learning model, so a and b and c, they are unknown to me, and my task is to learn the value of a, b, c by the given mapping of your input data set in such a fashion that my loss is minimized. So loss function will use to train the model or to make a comparison that which function is better. So if I'm using three different functions and I'm getting minimum loss, let's say using F2. So F2 will be a better approximation for the given data set on a for a problem at hand compared to F1 and F3. So based on this loss value, we can make a comparison. And how this loss is calculated. So for the calculating of this loss, it is a very simplistic formation. We are using here squared error function. So it is a difference between your given actual value of the output subtracted the predicted value. See here, yi is the given value or given output label, and f at 1xi is the predicted value of is the value predicted by your function on input xi. So, and we are computing it over the all given n instances. So the difference, it is pretty much clear from the mathematical definition and as well as the logical definition that we are taking two values. One is your original given value and one is your predicted value, and we are trying to minimize their summation. So we'll go or we'll choose the loss. So initially I don't know which uh, approximation model or will be the best for my problem. So I adopted three different models, F1, F2, F3, and I calculate the loss for all these models, and I will choose the model. So here the key problem arises, like which function is better. So that problem is solved by your loss. I will calculate the loss and I will go for the model which is minimizing the loss for my given problem. So assume here I'm getting the minimum loss using L1 1.38. So I will go with L1 rather than L2 and L3. And your common loss function in machine learning are the squared error loss, cross entropy loss, and KL divergence. So squared error loss generally we use for the uh, regression problems, where our final output is a numerical value. And cross entropy loss we use for the classification problem, where my final mapping or final predictor value is a categorical value. So now we have data, task, model, and loss. So how now the key problem is still we don't have any clue like how we'll get the value of these A, B, C. These are unknown to me. So my objective here that I have given some amount of some data set. Based on that data set, I have to learn the parameter ABC for the given approximation function such that the loss for that given approximation function or all training instances, which comprises from 1 to n, is minimized. So the mechanism here is missing, is that how to learn these A, B, C such that this loss is minimized. So general approach is learn it from the brute force method, but it is not very convenient and inefficient solution to learning these parameters using a brute force method. So we need a systematic approach to learn the value of these parameters. So here, the common learning function for your machine learning domain is gradient descent, RMS prop, ADAM. So basically, you can also find out the alternative name for this learning function is the optimizers. So it's all that given the problem and data set at the hand, you know the approximation functions, and we have to learn the parameter or the weight of models in such a fashion that it minimizes the loss. So now we have the learning algorithm. You can choose any of the given learning algorithm. So gradient descent is one of the learning algorithm. You can put one of learning algorithm here. And now final, we have to evaluate what we have learned. So for the evaluation, if it is a classification problem, generally we use accuracy, precision, and recall. So accuracy defines like if total number of predictions made by the model like n, so how many of predictions are correct. So you can check like here the true levels was 2, but your machine or the model you have trained is predicting 3. So it is not a correct decision. So that's how you make the evaluate. And if I'm not getting the required performance measure, so I will I have to retrain my model or I have to adjust my parameters. Or if it is a regression problem, so I have to go for the loss. So now these all are the building blocks. If I put all these components together, so this makes your the entire machine learning systems, moving from data to the evaluation. If it is my evaluations are up to the mark, then I can use this model to predict the given problem. So now there was a first myth that your AI will replace the job, but now we'll try to make that statement false. So here data that will be used by the humans. So here instructor will be human. Your machine can generate the data, but the instructor will be human. So we need the enormous amount of people for this, only for this data domain. If the data is not clean, so it's like the garbage in, garbage out. Where whatever best model you have, if your data is not correct, will not be able to make the correct predictions. So the data engineering and data analytics still needs use manpower. So still it is not going to replace you. Actually, in contrast, it demands more people. Second, the task. What kind of task or what is my application requirement? It is also defined by the humans. It is not defined by the machines. Third, the model. What kind of model I have to use? Whether it will be a classification model, whether it will be a regression model. If it will be a regression model, what kind of model I will use? Your machines can make recommendation for you, but final choice will be yours. So still we need humans here. Loss function will be defined by the humans or the particular person. It may be analyst or machine learning engineer or AI engineer. So he will define that function. And finally, here is the machines come into the frame. So that is automated. That learning will be automated. And finally, in the evaluation, we can't trust the AI models completely. So still there will be man in the middle. So among the 6 components, 5 components require humans, and only one component is fully automated. It does not require the interruption from the humans. So we can say it very bluntly that AI will not replace the jobs. Basically, it needs more expert from these different subtask domains to make AI more efficient for the upcoming time. So now these are the basic 3 categorization of your uh, machine learning solutions based on the task. So we already covered that part. One is your supervised learning, unsupervised learning, and reinforcement learning. So in your the key structure is like in your supervised based learning, we are having the mapping for the input and output data. Your output label is given to you. In case of your unsupervised learning, you are only have the input data. We are not given any output. So we'll use either clustering or outlier detection kind of technique to group the similar kind of data in a one cluster and non-similar into the other part. And finally is reinforcement learning, which is totally based on the human learning procedure. So here we learn based on the feedback received from our actions. And nowadays reinforcement learning, and particularly deep reinforcement learning, is a very uh, growing area, and it is utilized in various applications. So this is a mapping of the human brain, how neurons work in a human brain, how we map this working from human brain to the machines. So it comprises your input, weights, summation, and activation. So activations are generally your neurons are connected through some links that we call synapses. So here, and there must be a value for that particular synapses. So we call those weights. So based on our uh, involvement of various tasks and environment in surrounding environment, we learn those neurons and they will get activated or fire after a certain threshold is achieved. So similar kind of analogy we'll use in neural network, but here terminology is changed. Your synapses will become your weights, then your axon will become your activation function. So it is a mathematical mapping of how human brain works and how we'll map that working to the machineries. So basically, this is the simplistic representation of your multi-layer perceptron or artificial neural network. So initially it is the input layer, then hidden layers and output layers. So in your machine learning, we are having only this input layer, then your processing block, which is the model, and output layer. So in contrast to the machine learning, what happen in machine learning, from this input, we extract some features, and those refined features are given to the model for the learning. But your deep learning make it more simple in terms of your efforts to find out the features. Although you need more computation and more data, you have to provide more storage as well. But that feature learning is also a part of your deep learning. You don't have to describe those features explicitly. With the help of these hidden layers, your model will extract the essential features from the given data by itself, and then it will make the final predictions. So during the learning, it will take the input, will make the prediction. If my loss is high, I will forward those values back that for the adjustment of the parameter, which is called the learning phase, and we accomplish that phase using gradient descent algorithm. So this is a iterative procedure. Based on the input, I will predict the value, and if loss is not within the given range, I will reiterate it until my model is converged. And if model is converged and it is deployed, I will use only forward pass. So in forward pass, it will take the input and make the final prediction. So learning is a forward and backward pass phenomena, where your inference, which is generally accomplished after the trend model is deployed, is only forward pass phenomena. So here the two key terms in your deep neural network. One is your weights. So basically, weights are assigned on these links, and these are the parameters of your model. And these are initially randomly assigned. And by going through the iterative process on the given data set, we'll learn how these weights are looked. So still here we'll use all those 6 components: your data, task, model, learning algorithm, loss function, and the evolution to make this model final. So due to the time constraint, I am skipping this thematics. I verbally define like what procedure we follow. So in loss function and gradient optimization, I already discussed. In backpropagation, basically it's a chain-based rule which we generally studied during the calculus of our class. So it's a layer by layer, and if I get the loss at one layer, which will be backported to another layer. So that's how, using this chaining, I will reach from the output layer to the input layer and make the forward pass again to adjust my weights. So now there are the 3 problems which we generally observe in your machine learning and deep learning model, which is the underfitting and overfitting, also known as high bias, high variance problem. So in underfitting, what happens? Your model will be too simple. So we are not able to make the correct prediction on training data itself. And your overfitting, your model will be too complex, or you have limited data set such that it's memorized it. So it becomes the rule-based system. So we try to avoid these 2 problems and try to find a sweet spot where we'll get a good fit and low bias, low variance. So for that, we use the regularization, dropout, early stopping. So these are the common techniques which are used while training the model to attain that optimal balance or attain that sweet point of the loss. So this is a simple example for the image-based processing. So you are having initial image of the, let's say it's a mango fruit. Then you have multiple hidden layers. So in terms of CNN, they are called convolution layer and pooling layers. So what they do, they extract the key features which made those images. So it may be the edges, it may be the boundary, it may be the corners of the texture of that image. So all these features are finalized by these hidden layer, which is a combination of your convolution layer and pooling layer. And finally, we'll use a fully connected layer to make the predictions. Now the important topic for the session is your generative AI. So it will also use those 6 building blocks, but here the learning procedure and the task will be different. So key application is like text generation. It's a content generation. It depends on whether you are generating the text, image, audio, video. So it depends on your applications. And the models we are using here are your large language models, which is the combination of your deep learning model, particularly sequence model, and the nature concept from the natural language processing. And the one key distinction from this deep learning to this generative technique, that here your model is not learning on historic data set. It will learning from its contextual part. Like if I'm giving a sentence, so based on the given on that sentence, it will predict that what will be the next word. Then for the again next word, it will go through the all context. So it is not taking that use data set. That is the beauty of your generative AI solutions compared to other DL solutions. So these are the common techniques which we'll utilize in your everyday life. Computer vision, we already gone through the examples of your image-based task and video-based task, your recommendation system. So computer vision utilizes deep learning, natural language processing is your generative AI recommendation system. So it's like if you shop on some, let's say Amazon or Flipkart. So if you buy a particular product, so suddenly that 2 or 3 more products appear in your view. So that's how your recommendation work. It depends on whether your interest or the items purchased by particular customers in your region. So there are a number of factors we can consider in recommendation. Then autonomous systems, which is a suitable applications in your space-based applications as well. So now uh, within the given time duration, I would like to discuss the few applications of these AI technologies in space-based applications. So when I was working with Airbus, so it's generally they have two divisions. One is their production and one is their research division. So I'm specifically going to their what kind of current research that is going related to space applications and aerospace applications. So first key area is the predictive maintenance. So you predict there are three kind of techniques for the maintenance. One is your preventive, one is your reactive, and the next one is the predictive. So in your preventive maintenance, we generally follow the periodic approach. Like after a particular duration, like 1 month or 2 months, we have to repair the aircraft. So it may happen that during this period, your aircraft may not be used that much frequently. So why I have to invest through the duration and particular amount of money to service that product? Similarly, so that is a drawback. In reactive, if there is a fault occur, then I have to take the actions. So it may lead to very catastrophic kind of scenario in your aerospace applications. So it may lead to the crash of your plane as well. So reactive kind of maintenance is generally avoided. So in predictive maintenance, generally we try to predict that what is the remaining life cycle of this product. Or let's say if it is an engine. So they are trying to predict based on certain sensory parameters. It may be your temperature, it may be your vibration of the engines, and how many rotations it made. So they consider a number of parameters and they try to predict that how much life cycle of this product is remained. So it gives us two key benefits that I can, if I able to predict, okay, 10 life cycle or 15 life cycle is remain. So I can find out based on that information, I can find out how many days it will survive, and accordingly I can plan the maintenance. So my production is not going to stop, or my services are not going to stop, and in the meantime I'm also planning for the maintenance efficiently. So the solution from the AI technologies they are utilizing, so it is the artificial neural network, and the task is your regression task, and the performance metrics they are using is the loss. So based on the given certain parameters, so these are the tabular data set which comprises the entry for various parameters including your temperature, pressure of the engine, and finally we are predicting how many life cycle it remains. So this is the one of the key application of the AI technologies in your space-based applications. And second application which utilize the computer vision, and I also work on that, is the quality inspections. So this is related to their production plant instead of their communication research. So the production plant produce n number of various components, and if I go through the manual best checking and manual best testing, so it is much time consuming and there is a scope of error, because the level of the expertise of different workers on the floor may vary, or the mood or the work pressure, or a worker may feel like fatigue. So these are the different biases which can occur in human worker. So it may affect the quality of products, and which they can't tolerate, especially in case of your aerospace applications. So they are utilizing the computer vision based model which is used. So in the production line, it's a in-house kind of thing. So camera captures the image which sent to the centralized server, which is also located within the given premise, and it will identify whether the product is qualified for the next step of the processing line or not. If it is not, then it will be discarded and further identify like what is the level of error. So if it is less error, it can be going to the repair, otherwise it will be discarded. So they are reducing their faults as well as they are also reducing their scripts. So using the same technique, they are increasing their productivity as well as reducing their scrap cost. And final application which I'm aware, so it is regarding the pilotless aircraft. So there they are using the reinforcement learning concept. So the reinforcement learning concept comprises these autonomous aircrafts which will work as a satellite. Since our satellites are far and the cost of those satellite is much high compared to these your remote pilot based aircraft, so they can use these autonomous applications whether in security as well as your defense applications. So this is all from my end.
Okay, so thank you very much.
Now open for the
Hello.
questions.
Yes, thank you very much, Dr. Himanshu sir. Thank you so much for delivering such an insightful and intellectually enriching session. A wonderful explanation on traditional programming and machine learning, the importance of data as the driving force behind intelligent systems. How wonderfully explained the concepts of supervised and unsupervised learning using different models. So model building, classification. Thank you so much, sir. It was very resourceful and enriching session. So I can see some questions in the chat box. I'll just take one or two questions. Okay, so Mr. Sumit Mishra is a participant. He has one question. So it is in reference to the example of predicting Ebola outbreaks that you have presented. He says that if we lack a mathematical formula or a hard-coded rule to cross-check the algorithm, then how do we evaluate if the machine learning model is identifying genuine hidden patterns or whether it is just overfitting to the training data?
So
In such
for that,
cases,
so for that, in the different components we consider for the model building. So last part is the evaluation. So based on that, we'll identify whether it is correctly giving the results or not. And still there is a concept of no free lunch theorem. So we cannot say if your data is not correct, then however good model you will choose, it will not predict the correct value. So it's totally data dependent problem.
right. And another one is Mr. Solat is asking, how can we know that if a data is clean or not to train the model?
So for that, there are pre-processing data pre-processing steps. So in that check whether there are some like missing value is a common error. So if I am having a data in a Excel sheet, so it may happen that some values are missing. So that is an error. So common techniques are like I have to take the surrounding of value and I have to fill that value by the average. So for the detailed knowledge of that part, you have to go through the data pre-processing steps, like what techniques we utilize for that.
And one last is upon the loss function. So again, Mr. Solat is asking, is there any effect on using different types of loss function? I mean,
So
the
the loss
question.
function are defined based on what kind of problem you are solving. If you are solving a classification problem, the general approach is to adopt the entropy based loss function, because I will get some probability value. Based on that probability value, I will make the final classification. And if I'm going for the regression problem, so my final target is a numeric value. So I will go for the error based loss function. So that depends on what kind of problem you are solving.
Okay, thank you, sir. So that's all from the chat box. A very resourceful and insightful session. You can see the participants were engaging in the chat box and a very positive comments and appreciation. So thank you so much, sir, on the behalf of Center of Excellence, MPIT Gorakhpur, and collaboration with Triple IT Lucknow. So we extend our sincere gratitude to you for sharing your valuable expertise, academic insights, and rich experience with all the participants. It was a wonderful experience listening to you. Thank you so much, sir. Thank you. So moving on, over to Disha Manan for the proceedings.
Thank you, Darshan sir. Thank you very much, Dr. Gautam sir, for an insightful lecture. On behalf of the Center of Excellence, MPIT Gorakhpur and Triple IT Lucknow, we sincerely appreciate your valuable contribution. With this, we conclude our first technical session and move towards session 2. Our second technical session is titled as Machine Learning, Deep Learning and Generative AI, Principal Techniques and Applications, followed by an AI lab demonstration. It's my privilege to introduce our distinguished speaker for this session, Mr. Sachidanand Chaturvedi sir, Chief Operating Officer and Head of Artificial Intelligence Laboratory at the Center of Excellence, Maharana Pratap Institute of Technology, Gorakhpur. Sir is currently pursuing his PhD in Artificial Intelligence and Cybersecurity from IIT Patna. He holds an MTech in Artificial Intelligence and Data Science from IIT Patna, along with an MBA in HR and Marketing, and MTech in Software Engineering, and a BTech in Computer Science and Engineering. With over 15 years of rich experience in engineering education, artificial intelligence, innovation, academic leadership, startup ecosystem development, and industry academia collaboration, he has been actively contributing to advancing technology, driving education and innovation. His research interests include artificial intelligence, machine learning, deep learning, data analytics, software engineering, innovation and entrepreneurship, and engineering education. So we are truly honored to have with you us today. On behalf of the organizing team and all the participants, I extend a warm welcome to you. May I now request Sir to address the gathering and deliver your insightful session. Over to you, sir.
Thank you, Disha. And I hope you have an understanding of the last session, because we are progressing. We will progress, the from where the sir has, just give us give his last insight. We will progress from there and understand what really the machine learning, deep learning, and generative AI principles and techniques and applications are. In the last lecture, we came across that there is a new technology domain known as artificial intelligence. Am I audible to the audience? Just tell me once. Hello? Am I audible? Okay, sir. So in the last lecture, sir has already given you the idea what is the artificial intelligence and what is machine learning, what is deep learning, and we will in the next step we'll go through generative AI and how this generative AI works. First of all, I want to listen from your side. What really you understand about the artificial intelligence? Can you please share your insights in the chat box? What really you understand about AI? So I'm able to understand and comprehend how much understanding you have in this domain. What really the AI is for you? Anyone? Anyone from the 62 group? What really the AI is? What is AI for you? What do you think AI as a general man? Anyone? Mimicking the intelligence of a human being. Okay, good. Good, Solar. Maybe. So somebody has a AI for me is a technique through which our work becomes easy. Very good, Sanchita. Very good. So in the simple definition, we say that AI is the ability of machines or computers. AI is the ability of machines or computers to perform the task. Simple. AI is the capability of either ability of machines or computer system to perform the tasks that normally requires human intelligence. And what is the difference between capability and ability? Making machine systems smart enough to think enough. What do you understand by difference between the capability and ability? Do you know these two terms, capability and ability? Yeah, used to perform the task. Good. Now I'm moving towards the second question. What is difference between capability and ability? And now I want the answer from our audience. What is difference between capability and ability? Anyone? Capability is something to do. Ability is actually presenting a skills. Now, why I ask these two important terms, capability and ability? See, you as a human being, we are capable of doing multiple tasks at a time without any external inputs, because we are designed like that. Our genetics is designed like that we are able to perform the task as per the need. We need a learning process. Like when we born and when we start to walk, we try to learn. We try to learn by seeing the individuals around us. That's capability is within us. But we need to develop the ability. Okay. Capability is within us, but we need to develop the ability. Yeah, capability means that the potential to do, and ability means someone can do right now. Okay. So humans can do anything. Humans can do each and everything. What really this artificial intelligence or the part will do? What really this artificial intelligence or the part will do? It will help us in problem solving, which requires large amount of data. And why it requires large amount of data? I'm with you on the definitions what you have said, that AI is techniques through which the work becomes easy. Okay. Now I'm putting a question that what is capability and ability? Capability is something to do, and ability is presenting a skill. That's I agree on that. Now let's understand in the context of the AI, what is the capability of AI and what is the capability of ability he right now he is performing. Coming to the process, human mind has a neurological system and genetic codes. That is this capability. And when we work on ourselves, when we work on our learnings, we increase our ability to get the skill set through seeing the environment around us. Like we understand how to walk, we understand how to run. Okay. Then we understand how to play some games. Then we understand what are the rules of those games. Okay. These are the abilities we develop because right now we have a capability. So capability part is like a hardware of AI. If I say to you what really the capability part of AI, the capability part is the hardware of AI plus data what we are pushing in that hardware for the model training. Okay, so capability of AI machine is its hardware, data processing strength, and the model on which it is working. Am I clear or not? Am I clear or not? Hello? My voice is there any issue with my voice? My
No,
voice
sir.
is,
Your voice is very clear and audible, sir.
okay,
Please
okay.
continue.
So there is difference between capability and ability. I am, making you understand in the context of the AI. Now come on the definition of the AI again. So AI is the ability of a machine. I'm not asking about the capability of a machine. Capability we have already discussed. That the capability is the hardware of system plus the data, how much data it can process at the time, and on which model they are working. Like if there is a 6 GB RAM and I3 system, it will there in that capacity maybe large language model will not run. For that capacity, we need higher machines like NVIDIA S200. Okay. Now coming on the definition of the AI. So AI is the ability of machine or computer system to perform the task that requires human intelligence. Now coming on the part again, what really the intelligence is? Intelligence is to take the right decision at the right time. Single definition of intelligence is to take the right decision at the right time. Now, what I mean to say about this? That you have an exam by tomorrow, and there is a football final of World Cup. What you will prefer? Now, it depends upon your interest. It depends upon your choices. Am I right or not? Today is your examination. Yesterday you have this football final. Today, let's assume today is the examination day. What you will do? You will prepare for the examination, either you will see the football match. Obviously, exam. Sanchita Shukla has said about that. Why? How are you able to understand that the exam is more important? Because you are able to foresee the future. That this exam results is more important than the football World Cup. Because the football World Cup, we can rewind that. But the yearly exam is fixed on 20th and it is from 12 to 3. So we need, how we are able to understand? We understand that we have a focus, we have a long-term understanding of ourselves, what we really need. These things we need to put into the models. Okay, for this we need some capability building exercise through mathematics. So any model capability building exercise is mathematical understanding with the algorithms of the process. Now, coming again to the definition, artificial intelligence is the ability of machines, ability of machines to perform a task that requires human intelligence like learning, reasoning, problem solving, understanding language, recognizing images, and making decisions. On all this, we need a clear-cut objective what we want from our machine. And within the human mind, we have a pattern analysis, and our mind has some experiences we call as a memory, and those experiences are within us, and we use as it is needed. But we can't do this thing to the individual machine. Like individual machine can't be mapped as a brain, because brain is a very high functional, multi-dimensional intelligence unit. So we just pick one single questions, and for that single question we devise this data sets. What data sets is really needed to be get answered? In the last lecture, sir has already explained about that in the supervised learning you have already know what really the output is. So for that, and when we understand what is really output is, in the future when we again that situation, we push ourselves with the past experience that whether this is correct or not. And this process is machine learning, where we have a labeled data and predicted outcomes. What is unsupervised learning? Unsupervised learning is that let's go for a team in this rainy season. You never know whether the shop will open or not. You are just going with the hunches. This is unsupervised learning. And you follow a pattern like, let's assume Ram's shop will be get opened at in 9:30. Maybe he is open. So in that part, we classify the things in the way that this shop can be open, this shop cannot be open. So this is in this simple discussion, we find out a pattern and devise a model will predict our future. That is unsupervised learning. And what really the enforcement learning? If you want to take a correct example of the enforcement learning, see any child in your house. He sometimes don't drink milk because he don't like it, maybe. So, her mother gave an opportunity, if you drink this milk, I will give you chocolate. And if you don't drink milk, I will not give you chocolate. Like this, machines are also trained that if you do the right work, what is already defined, you will give an reward. And if you're not doing the work what is already defined, you are deviating a part, you will not get rewarded. So this is simple, common understanding of what really the machine learning is all about. You have already have a session of a machine learning. I'm not going to the very deep of it. Are you able to understand and comprehend what really the machine learning is and all three types? Anybody in the chat box? Anybody? So, what we understand in the last 5-10 minutes, that we need to create an environment where we will push our data for the learning. And this learning will be taken care as an experience, what really we call in the real world. But in the machine world, it is the pattern analysis. Machines make some pattern within the data and understand, and the next time when this data will come based on this pattern, I will predict this. Okay. A predictive features come within the algorithm, within the system. Predictive features of the algorithm help us to predict the new answers within the system. How it is working right now. Like you have gone through at some e-commerce website. You bought something. You bought a pen, and the recommended system is sharing you have an eraser also. How he knows that the person who has pen need a eraser also, because there is pattern of buying, and that data was already last 50 years data is already with us, and we have trained our machines with the predictive outcomes. Okay, so a recommendation system understand what next he needed. This is the work of the machine learning. Now, then when machine learning is doing each and everything, then why we need deep learning? This is a question. When we are able to perform our task with the help of the machine learning, why we need deep learning? Anybody? Why we need deep learning? If we have already a machine for complex pattern, good, very good for understanding complexity, very good. And what really the complexity is, we always say complexity. What really the complexity is? Complexity is parameters. And what really the parameters is? See, we always talk about data, and where those data are stored. Those data is stored in some, computing formats. Those computing formats can be in an Excel sheet. It can be a SQL data. It can be HTML data. It can be a PDF data uploaded in the website. So these are different file systems. If you know, you know. You can't open a single file from a single software each and every file system. You need a different application software to open those file systems. Now think, I need to train this much of diversity. So I need to devise a different parameters. Like every file system needs application system, we need to devise a different parameter to put those data within the algorithms. Okay. For this, like for the image and visual data, we use CNN data. For the sequential data like this, when we have varied parameters, we use RNNs. And when there is a NLP, natural language, when we comprehend natural languages, we use transformers. In transformers, there is a technique known as POS. What is POS? Grammar, what we use, part of speech, and that is the technique we usually use. So, for understanding the complex, what is complex? For understanding the complex, we need to understand what really the parameters are. And this particular job is taken care as a feature selection, which is a very initial process of any process. We need to get our feature selection done in going with the help of the principles defined within the machine learning, deep learning, and generative AI. Then only we are able to get our good AI. Why we are able to get a good AI? Because we are able to incorporate real world phenomena within the system. Because in the real world, we check out many things, then we take a single decision. We need to go for a tea in a rainy season. We will take umbrella. We will devise our path. We will take a path. We will take a path where there is a less, watery situations like that. We will go to the shop. There is a force of level. We will go to the shop, which is, we understand that he will be opened at this time. And that also needs some parameters, that because he function under his own home, there is a small shop, below and is their own home, what do you say, environment. So by simple one object, by pushing one objective to drink the tea, we are taking so much parameters within the system, and we are able to decide that okay, this shop will get open on 1 p.m. and we'll get a tea. That's why we need these type of algorithms. Third part is generative AI. I will teach you in the coming model. First of all, understand what really the data is. Now we understand any AI need data. Any AI. Any AI need data. So data is the foundation of AI. Okay. And accurate data will give us better AI system. And what is meaning of accurate data? Like, let's assume you are going to get an admission for an engineering college, and you want to make a system which student will take admission within an engineering college, and you are making your model train by the data with where the columns are of students who have learned biology in their 12th. That is not needed in engineering. So the accuracy of model will get biased. Okay, we will not get a right output. For the better accuracy, we need a high quality data. And what is the meaning of that high quality data? High quality data means pinpoint selection of the data according to the objective for which we are making the AI. Like for the healthcare, we need the disease diagnosis data. For the finance, we need the fraud detection data. For the agriculture, we need the crop. If we are going to make a AI system for crop predictions, we need to understand which crop will be sown in which season. In the manufacturing, if we go for the predictive maintenance, then we understand on which machine we are using. In the retail, if you want to recommend a product, like if I am buying a pencil and then I need a eraser, I don't need a milk. So these types of data need to be pushed in a manner which is a very accurate for the objective which we want to solve with the help of the AI. See, AI is a simple programming structure in which it can handle a high-end statistical data with the help, and there is algorithm present to process the data. This simple AI it is. So in real world, whenever we got our raw data, we collect those data, we clean those data. What is the meaning of cleaning of data? Cleaning of data means like, let's assume there is a data of some police personals, and some personals haven't write their date within that data. So that in that cleaning process, we have to ask for the date of birth for that police personnel to be given there. What is the meaning of data integration? Like within the HR process for the police person, there will be accounting data, there will be service file, there will be his finance file. For a single man, there will be a variety of the data. So for analyzing a better output, we will make a various parameters, and integrate those data sets. Then we transform the data set to get a better feature engineering. Okay. And then we go for some, then we use our algorithm and put that data for visualization. And afterwards, we get with the help of the model training, and then deploy them. Afterwards, when it is with common man, they will understand they will when they put any search operations for the police personnel, they will be able to get it. And for this, we used to get a data collection, data cleaning, data integration, data transformation, feature engineering, data splitting, and model training. And what is meaning of data splitting? Data splitting is like how we are training our data set. First of all, like 70 here it is showing that the 70% training data set. This data set is our past experience. 15% is the validation data. That is the real this data we usually take like on the data which we have right now, and we validate those data that we know this system works like this. And 15% for the future prediction, we put some random data for testing purposes on our models which we are able to train that. And what in that processing, what we get those challenges like in the data set there is a missing values, there is a duplicate records, imbalance data. There is a noisy data. What is the meaning of noisy data? Is like data we don't need. That is there, and some I don't know. So and some high dimensionality data is there. We need to make a AI for prediction of after 5 years what will the salary of the police personnel, but we are using a data of his health. That is the high dimensionality data we don't need in that model. On this discussion, we came across that there are three types of data. There is first is structured data, which is very structured, like databases, like Excel sheets, where simple name, CL number, all are written out there. Second is the unstructured data, what we usually create with our chats by Instagram Reels. And third is the semi-structured data. In the semi-structured data, we have a log files of the servers. And right now, we are also getting this streaming data as well. Now, this is the important part because data is the fuel of artificial intelligence. Okay. Coming to the next part, what really the model is. What really the model is. Everybody talks about model. To understand the model, think as a step. Okay. Your data is your ingredients for making some dish. And model is the recipe and methods. With the help by applying model, by applying the recipes on the data, which is known as ingredients right now, we will predict the dish what really we are getting. Okay. For the next time, if somebody will follow this process, we are able to predict what next is coming with us. So model is a mathematical function or algorithm that learns the patterns from the data and uses it for the decision making. It's a very simple thing because every time we initiate AI discussion, we miss those things what really the data is and what really the model is. Model is like y is equal to fx. Okay. Model is simple like y is equal to fx. So, and x on the value of the x, y is dependent. Okay. So that's what I am pushing from initial talk, that X is very important. Your data set is very important. Okay. And with the help of that, we make some actionable insights. So models learns on the historical data, like data which we have in the last 50 years, 30 years and all. Then models find some patterns with the help of the parameters. Okay. And after that, we are able to generalize those content. We are able to generalize. So goal of the model is to learn, to generalize, afterwards predict and create value within the system. Any model, whatever you are, whatever you say, there is some 5 components will be there. First is parameters. The parameters are the instructional set what we really need during the training. Second, on the which layering pattern we are getting our patterns. Third is on which algorithm we are working on. Fourth is what is the loss function, what has been defined in the last lecture by the sir, and what are our training data. So like simple, we all uses email. Let's understand there is an email spam detection model. Maybe something which is spam for me can be like somebody text me the roll number of JEE mains to me, that is spam for me. But the person who is in the 12th class, somebody has texted the roll number of JEE mains, that will be ham for him. So for on the individual basis, our email machine learning algorithm train itself and understand the patterns on which pattern of data this particular guy is needed, and they push those emails as per the experiences on the spam. Okay, so maybe a mail which has come from for JEE mails is spam for me, not the person who is going at 12th class, who is past his 12th class and given the JEE main examination. I hope I am able to clear you what really the model is and what really the data is. Now you understand that we want to predict the future with the help of it. So we have a certain models to getting this thing done. When we want to predict a continuous value, we use regression models. When we want to predict the categories, then we go with classification model. When we have a similar data points, like a customer is there who is there to buying on the pant shirts, but whether he will able to buy a t-shirt or not. In that part, we use clustering model. And what is generative model? You know, generative models, like we have already trained our data, we have already have patterns, we have already have experience. It will help to generate a new data. Like this particular slide is generated by the generative AI ChatGPT. That's why I am taking it. So, and there are recommendation system as well. So what really the model is? A model is not a code. It is a learned system that captures knowledge from data and uses it to make intelligent prediction or generate new content. Let's understand in deep what really the data is and what really the model is. Now coming towards, let's have a summary of machine learning. Sir has already explained this, what is machine learning and what there are types. So I will go quickly on this for every reason part. That the machine learning is a subset of artificial intelligence, which enables computer to learn patterns from data and improve their performance. There are three types of machine learning. When we learn from a level data, then we use supervised learning. When we learn from unlabeled data, we call it unsupervised learning. And when there is a reward system with the help of there is a reward system. If you do something correct, then we will get rewarded. Then it is known as the reinforcement. And for this, we have many algorithms. Like linear regressions is used for the predictions. Logistic regressions we use for classification. Decision tree we use for the classification regression as well. These are the mathematical algorithms which is already present with us. We are using to process the large amount of data with help of to get our machine trained. And for that, we introduce many concepts like training data. Training data is used to train the model. Testing data. Testing data is used to evaluate the model, whether the model is working the right track or not. And from that, we get two types of things: underfitting, overfitting. When model performs well on data, but poorly on the new data, like we have taken example last 50 years of the police HR data, but let's assume when we put new data on that model and it is not giving us the right insight, then it is a overfitting model. And but when it is the underfitting, model is too simple to capture the patterns. We are not able to get the patterns. And here the sense of choosing an algorithm is very much needed. Which algorithm we need to choose for getting a job done and within a certain environment, what we are talking. So capacity and versus ability. So we need to understand the capacity of the system. So future will perform according to its ability. In the real world, we use machine learning in the healthcare, in the finance, in the retail, in the transport, in the manufacturing, in the cybersecurity threats as well. So overall, there are three insights. First is any machine learning work is a work of quality data. For quality data, when they get trained on the quality data, and for that quality data, we have a set of process. We need to follow a processing pipeline. This is basically a work of data analysis as well. Then we get a raw data, and we collect the data, we clean the data, we integrate, we transform. There is a feature selection, then there is meeting for whether there is a training data, whether there is a training data, in the validation data or testing data. Then we train our models, then we go to it. Okay. And what is the label and targets? Label and targets, on which label we want our output. And what is the model? Model is a simple mathematical representation, but we learn from data. So this is what a machine learning is. I want some what happened if machine learning is not available for AI? If machine learner, in between I want from you said whether you are able to understand the machine learning or not. In between, I'm going to answer the Devans Ranjan. What happened? His question is, what happened if machine learning is not available with AI? Then it will only work like a past expert systems. Past expert system usually works on if else. Machine learning algorithm give you edge to predict the future in a more confident way. The past, the expert system were working on the if else technology. Okay, nothing will happen. The prediction, the future prediction will get down. The what we say that the correctness of the prediction we can't get down by not using the machine learning concept. Anyone? Are you able to get a insight of machine learning or not? I need a one message in the chat box. Solakari, yeah, thank you. And I have explained your answers as well. That if we are not using machine learning, then we will go for the rule-based AI, and where if we are using if else, simple if else based expert system, simple expert based systems. So now I got my answer. Let's move to the principles of machine learning. See, let me tell you one thing. Machine learning is not about programming computers. It is something to enable the data and improve our experience. So for this, the basic principle is data first. Quality of data should be according to the requirement of the questions, what you want to solve, requirement of the problem. And in between, we need to study hard each and every algorithm and predict the best method from which we are able to get patterns from the historical data. After that, when we are able to do this, we will use a generalization techniques, okay, and make a label data in a simpler form, okay. And what is the optimization? See, we can't provide our 100% experience in any case. See, that's why our model works in like 89%, 90%, 92%. So for managing those laws, we use the concept of optimization, and it's a continuous process going on within the system with various evolution metrics. Okay, like accuracy, precision, recall, F1 score, ROC. For the task type like classification, for the regression we have MAE, MSE, RMSE, R square. For the clustering we have Silhouette score, Davis-Baldwin index. For the ranking we have MAP, NDCG, precision, recall. These are the evaluation parameters what we use. That's why let me give you a clear insight. If you want to learn a machine learning and you want to be a machine learning engineer in space tech also, these are the basic things you have to study. You have to study the mathematics. You have to know how to make your hand dirty with the data. After that, we put our model within the iterations for the continuous learning process, and then those two things we need to take care. The model should not be underfit, either overfit. Okay. If we are training those, if we are performing the training, we need to ensure that when we put new data, model should give a right objectives what we really need. Okay. These are the simple core principles what really the machine learning should take care. Okay. So what is the really the machine learning algorithm workflow? First and foremost is the problem definition, because without problem definition, nothing can work. You are not able to define your capacity part. How you will predict the ability? For the capacity building, we need a good problem statement. According to the problem statement, we need to collect the data, relevant data. After that, we need to prepare the data according to the requirements of the model training. For this, we should use the feature engineering. Then we put those data for the model training and in the evolution patterns, in the evolution matrix as well. For the we have already I can't discuss this because it's a very large thing. You just understand there is an evolution process as well. Afterwards, when these parameters are get off, we put into the deployment and monitor the performance. And a feedback loop process always go on. There is a whenever the new data comes, it retrain model retrain itself and improve this. That's why ChatGPT of 2024 and ChatGPT of 2026 is very different, because we are giving enough data to ChatGPT to train itself and improve itself. Example is, everybody has made an image from ChatGPT of its own. A trend has come. The trend was Ghibli images. So we all give our images and ChatGPT got trained. Now ChatGPT is making this much perfect image. This slide which I am using is from ChatGPT, and see the one simple prompt give me this beautiful slide. How? Because we give our data through the Ghibli, what you can say that Ghibli tsunami comes in the last year, and they train themselves. Now they are able to give a good, good insightful data in the form of image. So any machine learning process, understand the problem, explore the data, start simple, check for the cross validation, and document and track experiment and continuous monitor whether it is working or not. Real world application, you are living in the machine ML world. Recommendation systems in healthcare, fraud, autonomous vehicle, sentiment analysis, email spam, sales forecasting, predictive maintenance, customer segmentation. Everything is having a machine learning. Now coming to the techniques, that techniques is like the mathematical part of the data, capacity building part, from which they are able to, they are able to predict the future. They were able to, enhance the data sets. Enhance data. They are able to predict the future according to their training. So, what are really the techniques are? Techniques are helps us to identify the patterns and make the predictions. Right? And from with the help of the prediction, we are able to make our decisions, which improve our performance over time. Okay. Now, coming to the techniques within the arena of machine learning, there are three types of machine learning we have. That is supervised learning, which has already a labeled data. Okay. So ability is right now here defined, that you have a labeled data, train yourself with your capacity and give me the future prediction. So what happening? We have these linear regression, logistic regression, decision tree, random forest, SVM, KNN, naive Bayes, gradient boosting, ANN. These all are the algorithms, you can say that, either mathematical models, you can say that. These are all present within this Python environment, which we can use to solve our objectives. For the unsupervised learning, we have a K-means, hierarchical clustering, BB scan, Gaussian mixtures, PCA. These association rules, autoencoders, TN. This much of complexity is working behind any AI system. I'm not saying this AI learning is easy. AI learning is very complex. And for the reinforcement learning, we have a Q learning, we have a deep Q, we have a policy gradient. These are the algorithms. These are algorithms. Let me give you one example. What is the purpose of this algorithm? Like, I will not give. We have our time. This one. We have our time 45 minutes here. And with 45 minutes, I will make you understand how this mathematical understanding comes with the programming. Let's now focus on the linear regression. See, linear regression, we understand that it's in a method, it's a where it is used on the supervised learning. And what is its mathematical equation? Linear regression mathematical equation is y is equal to mx. सबसे पहले definition देखना है. What is the definition is? It is in a model. Whenever it is model, we work on a data, and for data we need some mathematical equation. And what is the mathematical equation? Here it is y is equal to mx plus b. Okay, and for the multiple variables, like in the multiple parametric sense, we have w weight, that is coefficient, and bias, that is intercept. So y is equal to w1 x1, w2 x2, w2. This is simple mathematical equations. And what is its geometrical interpretation? Geometrical interpretation that if we draw the results, we are able to get a single moving line. And when we use those things, when we use our linear regressions, we use our linear regression to predict the relationship between two things. Like in the month of July, house rents get increases. Why? Everybody from the village part come to the city for education purpose. So house price will be get increased. House rent will be get increased. And for the code, see, we are simple taking the help of the sklearn, and we select the model and import the linear regression. So this is the why we are using the Python within the system, because Python has already shorted this all complexity by having a models within itself. Like in the sklearn, we have a model. We used to select a model, and we select a model. Like what model we right now using? A linear model. From where we get those linear model? From the linear regression. And what matrix we will use? Mean square error matrix. When you implement these things, so Python is what? Python is a programming language. Scikit is what? A environment where these all things are made up and we can use it directly. How we are going to train ourselves? When we will give our sample data and we will split those data for the training and the testing purpose. Afterwards, we will create a model with help of the linear regression model already built in within sklearn. Afterwards, we will predict. We will give our we will take a prediction from that. So, what I'm saying, this is a clear-cut analogy. Behind the principle, there is mathematics. Why we need not to take care? Because it is already taken care by the various Python environment thing, like sklearn and all. Now you understand why everybody say to learn sklearn, learn Python libraries. Why we need to learn the Python libraries? Because Python libraries help us to reduce the complexity to read and understand each and every mathematical concepts used within the model training. Okay. Like this, we have many techniques, and there are many libraries as well. You have how much libraries you all know? How many libraries you all know? How many libraries you know from Python? This is the next question. How many libraries do you know from Python? How many libraries are there in Python? Anyone? How many libraries are in Python? I'm asking to you all. How many libraries are in the Python? Libraries. How many libraries are in the Python? Like NumPy, Pandas, Matplotlib, Plotly, Seaborn, Skitlearn, TensorFlow, PyTorch, OpenCV, Hugging Face, Transformers. These are what? These are libraries. These are libraries actually. And what are libraries? Libraries has the programming already programmed the mathematical concepts and which we directly use within our model. Are you able to understand this? Yes or no? Are you able to understand this or not? Libraries are something that they reduce our complexities. Yes, Anshika, very good. They are more than that. It's depend upon. That's why I am saying it's not a one day job. It's a learning activity. Whatever problem you solve, you will find those libraries. Let's find that library, whether it is available or not. Need not to create a new library. We need not to reinvent the wheel. We need to understand what problem we want to solve. What problem we want to solve. That's where comes the application part of machine learning. That's where it comes. We need to solve the problem of healthcare. There, for detecting a tumors from the MRI scan, then we need a MRI scan detector. Then we need something which helps us in the CV detection, computer vision detection. So what libraries are used in the computer vision detection? How we are able to do this? We have OpenCV, we have YOLO, we have PyTorch, we have TensorFlow, Keras. Okay, these are libraries actually which will solve this healthcare problem. Like in the finance, what type of libraries we use? What type of libraries we use in the finance? We use Pandas, NumPy, SkyFi. There is a one API of Yahoo also, Yahoo Finance. Like this, we have a libraries for retail also, retail. Pandas, NumPy, Skitlearn, TensorFlow. These are the very famous ones. But right now, many libraries are there. Streamlit is there. Because right now, in the getting a model run, still we are using Streamlit because it's able to get trained with the interactive web apps as well. So this is the various sector in which machine learning getting applied. But how it is getting applied? By getting a clear problem statement, by getting a selection of algorithms. After selection of algorithm, next step is the selection of library in which you want to work with the Python infrastructure. Okay, so any domain, what I say, healthcare, finance, retail, manufacturing, transportation, cybersecurity, energy, agriculture, education, media, human resource, marketing, real estate, government and public sector. These are the verticals. These are the verticals. What we need to understand, the process is same. We need to get a good data, and we need to validate that data with the help of this process, data cleaning process. We need to get a feature selection. On the feature selection, we will train our model. And model is what? Model is something algorithm. Algorithm is what? Behind the phrase, it is a mathematical concept. And what is those mathematical concept? How we are using that mathematical concept? Because we have a libraries. Because we have libraries. Libraries has already built the programming of those things. We will use those libraries and build our model. So we can develop any system right now because programmers are working day and night to make to get get the libraries rich, open source, because that's why machine learning is growing in the open source environment. Everybody is working on different problem statement and they push those solutions within those libraries. So this is a somewhat a pathway on which we do our machine learning thing. And it is for space also. We can do like this. Within the space also we will do like this. So, end of the day, we have a comparison of various machine learning techniques and applications. We have a regression, which is a supervised, predict the data. We have a classification, we have a clustering, we have a dimension reduction, association rules, and all. These are names, sir. These are names. The process that we have discussed that need a simple 4, 5, 6 steps. Data problem statement, data collection, data cleaning, feature selections, model training, for training, how much we go for the validation, how to validate those models. We need different things. So for machine learning techniques, we have regression, classification, clustering, dimension detection, association, anomaly detection, ensemble, recommendation system, time series forecasting, NLP, reinforcement learning, semi-supervised learning, transformer learning, online learning. Now, machine learning has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 other ways to solve our problems. There are 15 plus techniques to solve our problem. That's why it is very correct. We have 88,000 plus libraries within our system. Thing is that in the machine learning environment, now it is very easy to solve the problem, but we need to understand our problem statement in the right manner, and our data should be very correct. Programming part can be taken care. It has become easy due to the availability of the libraries, but still sometimes new complexity arises. I will not say that programming is easy. Complexity arises, it need to be get solved for day and night. Are you able to understand the overall journey of the machine learning till date? We use model to learn patterns from the yes from till time. Are you able to understand what really the machine learning is? Then we move towards the high complex environment of learning. Yes, thank you, Devesh. Now, moving towards machine learning. We understand the process, but there is many hidden layers within the pattern. For like this, how the inspiration of this is our neurological system within our brain. Sometime in the toughest situation, we get our best decisions. How? Because brains are able to process some hidden layers within ourselves and give us right direction. On inspiring Anna, it gets us on top of it, we act. Okay, like we act like whether this is required or not. That the hidden layers give you the direction, and we act on our own consciousness whether it is required or not. For this activity, the activation functions is needed. Whether I need to do this thing or not. Like somebody, you are going with auto rickshaw, somebody just snatch your head, pull your hair. Whether you will react and get into the dirty fight, either you will just avoid it and go into your job, what you are doing. This depends on the activation functions, and these are very non-linear things. And these action functions are ReLU, Sigmund, TANS, many are there within the mathematics, within our domain. Are you able to understand what really the activation function is? Activation function is like, if I to perform this, I have the, with the help of the ANN, CNN, I am able to understand the neural network pattern. I am able to, with the help of the soft computing, I am able to understand the patterns. But whether I need to act on that or not, we need activation function. Okay. What is the loss function? Like in the when we compress our data, this becomes very important. That quality of data should not be reduced. That we take care through loss function. What are the optimizers? Optimizers, again, capacity building and ability. To make this understanding between two, we need optimizers. And what are the regularizations? Regularizations is like we take a real world context and make him available that in the real world this problem is getting solved like this. How you are going to solve it? And from there we get our hyperparameters. Okay. And in which batch size and epochs we should go. And this is a become little bit little not. I'm just explaining in a very easy manner, but it is a very complex concept. When you work on it, when you work on a deep learning, it is a very complex concept. But again, that all thing has been taken care by our libraries. I request you to go to the internet, get some projects of machine learning and deep learning and do it by your hand. Then you are able to understand what really the process of model training is all about. Okay. We have, and I had learned many things from the Kaggle. So you can go to the Kaggle and get yourself trained on the Google Colab. Now, focusing on the deep learning, how this complex pattern we get from this deep learning methods. How we get deep learning patterns? How? We need to understand that. So again, problem statement algorithm. If we need a problem statement for any image, we will go for CNN. If we have a problem statement for the sequence prediction, like protein synthesis and all, then we go for RNA. If you have a problem statement for the NLP, natural language processing, like Word, GPT and all, because ChatGPT works on the GPT transformer. So then we take this part. First of all, we need to again decide the problem statement and what are the architect we need to go for a deep learning process. Deep learning works on very varied amount of data, like image, audio, text, video, time series, graphs. It caters each and everything because we have a deep learning architecture available for each data sets, like image data set, audio data set, text data set, video data set, time series data set, graph theory network data set. That's why you are getting so much AI right now, so much AI companies, so much things, because on which part you are focusing, there is the opportunity. But ChatGPT becoming initially it was only a natural language processing. Right now it is also a image generation thing. Okay, they are also producing some videos, but they are not good at it. But there is some specific AIs which produces good videos. There is specific AIs which produces good audio. Okay, so right now we are in an age where we have a full stack of the various AIs. How it is possible? It is possible to this deep learning pattern analysis, and we are with the research we are able to categorize the architectures. The CNN is for image, RNN is for sequence prediction. Transformers is for NLP. Okay. And how this deep learning model works? First, we forward pass the data. We pass the input data. Then we observe how the model is behaving and analysis our loss function. Sometimes it is cause a loss entropy. Then back propagation often with the concept of the chain rule, back gradients, we compute the gradients. Afterward, weight, we update the weights. Like what is meaning of update the weight in the real life? I mean, example and review the real scenario. Like you always travel from your home to your school, your home to your school, your home to your school. Right now you are traveling. Let's assume you got a job and you are traveling from your home to your job place, your home to your job place. So my past data maybe have the weightage of the pathway of home to school, but right now I'm moving towards home to my job location. So this deep learning algorithm itself adjusts the weight and minimize the loss function. This is the beauty of deep learning, and from which I'm saying, from which I'm putting the concept that it is able to decipher the hidden layers. This was very tough within the machine learning algorithm. Okay, that's why there's two things are very much important. First is activation function, and second is the weighted options. Okay. Now coming to the applications of deep learning. What is the application of machine learning? It's advanced level application. It's advanced level applications is like computer, is like deep learning applications. Like right now we can get an image, and by image we can predict whether it is a car, whether it is a person, whether it is traffic light. With the help of the deep learning, we are able to do NLP, machine translations, sentiment analysis. With the help of the machine learning, we are able to do speech recognition and synthesis. With the help of the machine learning, we are able to generate a better recommendation system, better healthcare system, better autonomous vehicles, because they are able to update their weights, they are able to update their activation function, they are able to train itself fast. Prime series models. In manufacturing also we are using. Okay. And best use of deep learning is right now going in the direction of the pharma industry. If you are new to this domain, at least make one project on pharma with the help of deep learning architecture. Okay. And right now we're talking about the space. Get a better forecasting mechanism with the help of the machine learning algorithm and deep learning algorithm. It will clear our concepts of really the deep learning and machine learning is wrong. So these are the common learning models: CNN, YOLO, transformers. Simple समझो आप. If simple समझो आप, how this all architecture is working. Because it is some technical topic, maybe. Solar, why we? Now I have a question. Deep learning train models by using dataset. Yes, baby. Yes, Brahmanandji. Deep learning also get trained by the datasets. See, we need to, in the discussion, I will give your answer, Solar. Why we need to back propagate? Because we need to enhance our activation functions and weight as well. We need to enhance our weight. Okay? Are you able to get it? Solar. Any more questions from your side? In real world, a loan approval example, how does feature engineering turns a raw data of the raw data of work into? See, in general, date of birth can give you the idea of, in general, the date of birth can give you the idea of what really your age you are right now. And we understand that usually people start, you know, get their job by after 22 years or 21 years. This so from this feature selection, we are able to comprehend that and will push this information within the machine learning algorithm, either deep learning algorithm architecture, that predict the risk of loan to 20 plus, 21 plus and 21 below. So when the age of any person is less than 20 years and he has already taken the loan, the risk of doing a fraud is high, because everywhere in general it is assumed he is not doing any job, he is dependent upon his guardians. And somebody who is of 21 plus age, maybe he is doing the job 60-70%. So they were able to repay the loan in the right manner. So this way we can use that. See, सुमित, कोई भी एल्गोरिथम किसी को रिप्लेस नहीं करेगा. मैंने आपको बताया ना, डिपेंड अपॉन द R&D. हम क्या R&D कर रहे हैं. जिस एल्गोरिथम के बारे में हमें ज्यादा से ज्यादा पता होता है, हम उस सिस्टम में उसी आर्किटेक्चर को यूज करते हैं. जैसे गवर्नमेंट ऑफ इंडिया को अगर हमें इमेज विजुअलाइजेशन के लिए यूज करना है तो हम CNN ही यूज करेंगे. ओके, देखिए अगर हमको इंटरनल ऑफिस में, इंटरनल कॉलेज प्रीमाइसेस में, इंटरनल हाउस प्रीमाइसेस में करना है तो हम ट्रांसफॉर्मर्स का कर सकते हैं. क्यों? क्योंकि ये R&D एक्टिविटी है. इट्स डिपेंड अपॉन द प्रॉब्लम स्टेटमेंट जो स्टेक लगा हुआ है. रिप्लेस कुछ नहीं होगा. डिपेंड करता है कि हम उसका जो हमारा प्रॉब्लम स्टेटमेंट है वो उसकी एक्यूरेसी कितनी आ रही है, उस पर डिपेंड करता है कि हम एल्गोरिथम क्या चेक करें. तो कभी कभी हम 2-3 एल्गोरिथम लगा के चेक करते हैं कि जो सिस्टम है वो किस पे ज्यादा एक्यूरेट फिट बैठ रहा है, ट्रांसफॉर्मर्स पे या CNN पे. तो रिप्लेसमेंट नहीं आएगा, यूजेस का डायमेंशन बढ़ जाएगा. जो जितना एक्सपीरियंस होगा उसकी एडेप्शन बढ़ेगी, जो जितना नेव होगा उसकी एडेप्शन मिनिमम रहेगी. समझ आ गया? यस और नो सुने. Now coming to the next part. ये स्लाइड आप लोग ध्यान से देखिए पहले, फिर मैं पढ़ाऊंगा. What you are able to get, there is a raw data, there is a low level feature selection, there is a mid level feature selection, there is a high level feature selection, then we are able to get a task output. Okay, how it is possible? Through the neural network architecture, from enhancing itself from a simple to complex network. And how we train those data? We train those data with the help of the loss function and always update our parameters. ये मैंने आपको ही बताया, आपने क्वेश्चन पूछा ना बैक करने का क्यों जरूरत है, और क्यों जरूरत है, क्योंकि हमको लॉस फंक्शन को मैनेज करना है. तो हम जब ट्रेनिंग डेटा से अच्छा परफॉर्मेंस पा लेते हैं तो अनसीन डेटा पर भी चेक करते हैं. वो वहां पे अगर अच्छा परफॉर्म कर रहा है तो हमारा मॉडल अच्छा है, अगर वो अच्छा परफॉर्म नहीं कर रहा है तो हमारा मॉडल खराब. सिंपल फंडा है. कई बार अब आप स्पेस की बात करते हैं. स्पेस में हमें मालूम ही नहीं है कि जो डेटा हम कलेक्ट कर रहे हैं, ये डेटा किस डायरेक्शन में हमको लेके जाएगा. तो ऐसे समय में कौन सा एल्गोरिथम यूज होता है?